Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syamimi binti Abdul Latif. My matric number 181091335. I want to present my assignment, which is assignment 3 for question A until question F. For the question A, the total load needs to be supplied by the all generators are 650 megawatt at frequency of each generator. The formula to find the total load is P equal to SP F and no load minus F SYS. So for the final answer is Fn equal to 50.85 Hz. If generator W, generator X and generator Y supply 200 megawatt each, generator Z must be supplying 50 megawatt. The no load frequency of first Z is F and LZ equal to 50.59 Hz. For the question B, the system loads rise to 725 megawatt and all the generator set points are constant. New operating frequency is 49.78 Hz. For the question C, due to situation in B, now the operating frequency must be restored to 50 Hz. Propose the action of swing generator in order to achieve this. So the answer for frequency no load is 51.47 Hz. The question D, estimate the voltage regulation of these three generators under condition in D. The answer is 4330.127 and negative 31.79 degree ampere. For question E, we know that the VT is 40 kilovolt. Then we can find the V phase. The formula for V phase is VT divided by Z3. So 40 kilovolt divided by Z3, the answer is 23.09 kilovolt. So the power factor is 0.85 lagging. So cos 0.85, so the answer is 81.09. So we can find the IL. So the formula for IL is P rated divided by Z3 VT cos theta, and the angle is negative 31.79. So the answer is 4330.127 angle negative 31.79. So the voltage regulation for question E is 12.69%. For question F, I choose the improvement of reactive power dynamic response for virtual synchronous generator. For the theory, the basic idea of original virtual synchronous generator, which is VSG, is the P is almost determined by power angle, while Q is almost determined by voltage amplitude VT. So it's designed to be controlled only by P and Q only by VT. This basic idea is acceptable when VSG is interfaced to the grid inductive line, but not available when the resistance of the connecting line is not negligible. In this case, obvious interaction between active and reactive power exists in VSG control strategy, which aggravates the power oscillations. Moreover, the adjustment of P is usually much slower than Q. Thus, rapid reactive control cannot be achieved due to the interaction. For the methodology, VSG control strategy to improve reactive power dynamic response. Decoupling control method to suppress power oscillation of VSG in distribution network, but this decoupling method does not focus on the decoupling of P and Q, so rapid reactive power control cannot be achieved either. These have two analyses, which is response to active power reference step and response to reactive power reference step. For the response to active power reference step, the VT will be increased by the Q deep through the Q until VT control loop, then resulting P to get higher up to significant overshoot. After P reach P reference start to decrease and result Q to increase up to Q ref, then VT is decreased to make P decrease. So the active and reactive power has to suffer from a long oscillation due to the interaction described above. After correction, there is no variation in Q anymore. When the P ref step occurs, then overshoot of P is decreased and no oscillation occurs in Q. So in this figure, we can see the waveform for reactive power and active power. For the response to reactive power reference step, simulation are also carried out to test the effect when reactive power is adjusted. Pref is set as constant of 0.1 SP megawatt. In this case, and Qref is set as 0 megawatt at first and step of 0.9 megawatt at 2 seconds when damping factor D is 0.25. That's the response of the power before and after correction is shown in this figure. Finally, for the discussion, the original VSG control diagram has a problem of obvious interaction between active and reactive power, which bring oscillation and current overshoots during tracking power reference in distributing network. A method is proposed via introducing corrections into Q until VT control loop according to power angle sigma in this paper. Simulations are conducted in different cases to validate the effectiveness of the proposed method. When P is adjusted, the method can keep Q unchanged and suppress current overshoots. When Q track Qref, it can also eliminate reactive power oscillation, suppress active power oscillations, and accelerates the reactive power response. That's all from me. Thank you.